both problems you're working on are due, well, okay, you guys all know we don't have school Monday, right? So you guys will be here Wednesday and Friday next week. So Wednesday when I see you, you will give me those as well as the homework that I will assign on Tuesday. I gave you the notes handout for section 2.3. I just want to talk about the first little bit. I'm not assigning any homework over it today. On Tuesday, I will get through probably the next portion of those notes. I'm still not going to finish the section Tuesday. So watch the video. There will be a handout posted in classroom for homework on Tuesday. And Wednesday when I see you again, we will wrap this section up. So we'll be on it for a few days. You guys have been calculating limits, but I think we can all agree after you've worked on this for a while that it's kind of annoying, isn't it? Making those tables and plugging in all of those values, it's very time consuming. And you definitely don't want to do very many problems like that because it takes a long time. There are some things that can help us. So these limit laws I'm talking about, first of all, if you're not done with the homework that you're working on, you can't use these laws on the homework that you're finishing for me, okay? This is for starting next week. Don't go back and use those for the last few problems. But these are some shortcuts that we can use. This box is on here. I just wanted to kind of talk about these so that we have an idea what some of them mean, and then I can jump in Tuesday actually working examples and using them. So I just want to talk about the background. We aren't even probably going to get to any examples today. If you have two functions, f and g, and let's suppose both of these limits exist. So the limit as x approaches a exists for both of them. We get an answer. Then we have all of these rules that are true. If I want to add those together, then I could do the limits individually and add my limits together. Okay, same thing if I have the limit of f minus g. You can do their individual limits and subtract them. Same thing if we are multiplying. Same thing if we are dividing, with the exception that we all know if you're dividing, you can't divide by 0. The other rule is if you have a constant. So let's say my function was, let's say you knew the limit as x approaches 5 of x squared. Let's say we knew that was 25. If I asked you to find the limit as x approached 5 of negative 3x squared, it's telling us if you have a constant like this, you can actually pull that out in front of the limit, or sorry, not a constant, a coefficient. If I'm multiplying by a constant, so it's just a coefficient, I could take that out. And I already told you that the limit as x approaches 5 of x squared was what? 25. So now all I have to do is 25 times negative 3 to get my answer. So this helps us if we know the individual limits of f and g. We don't have to start from scratch when I want to add them together or multiply by something. We can use these laws to apply what we already know. Let's maybe do an example using a graph to illustrate this, so not any equations, just looking at a graph. So this beautiful picture has two different functions. I know your black and white handout is not color-coded, but there's the pink one is f, and the blue one is g here. We did that handout that we graded today, where we evaluated all those limits and using our graph. If I ask for on part A, the limit as x approaches negative 2 of f of x plus 5g of x. Well, I don't have have to go to my graph and find f plus 5 times g. We can use our laws and say that means limit as x approaches -2 of f of x, because I can take the limit to each of those. The 5 we know we can write in front of our limit. Now, is this something that we should be able to solve? Because we can look, as I approach -2, f is going to, do we want the point or where the graph approaches? Where the graph approaches. Remember, a limit doesn't care what happens at the point itself. It's as you're coming in from the left and the right, what y value are we approaching? So that would be 1. As I approach -2 on g, that one is giving me -1. So we get 1 minus 5 or -4. B. What do my limit laws tell me I can do on this one? Take the individual limits and multiply them together. We can do the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x. So on f, that's my pink one. When my x approaches 1, we're coming in on this graph and we're getting a y value of 2. Times, as we approach 1, g of x. That doesn't work, does it? You could do a left or a right hand limit, but can I do a two-sided limit at 1? So if one piece of this does not exist, what do you think the answer is for the whole problem? Does not exist. Because I can't do the limit at g. Okay, C, I'm asking for the limit of the quotient, so all we have to do is the individuals. So the limit of the top divided by the limit of the bottom. So f, as x is approaching +2 this time, what's f going to? 1.4-ish, not quite 1.5. We'll estimate. Limit as x approaches 2 of g. So g, I can't approach 2 from both sides. What are we getting? 0. What happens if you divide by 0? Can't do that. So my answer is, again, does not exist. So, how much time do I have? 2 minutes. So I'm going to have to stop here today. Tuesday then I'll pick up, we'll discuss the rest of the laws, and then we're going to start looking at equations, or expressions, evaluating the limits of those. If you guys could clean the desk, Lauren, do you want to hand out paper towels? Blake, would you mind spraying for me? And then if you guys are having any trouble with this